Alright, welcome to 3.3. The goal for this lesson is for you to be able to graph systems of linear inequalities. Alright, before we get started, I want to see if you can graph this inequality, so pause the video and try to graph this. Okay, let's see if you graphed it correctly. So hopefully you recognize that 2 is the y-intercept, so you went up 2 and plotted your point on the y-axis. And you notice that 1 was the slope, so you went up 1, right 1, and plotted a point, or you could have went down 1 and left 1, plotted a point. And when you drew your line, it should be a solid line because of the symbol less than or equal to. The or equal to makes it a solid line. If it was just less than, then our line would have been dotted. Now the last part of graphing an inequality is to shade. And so if you don't remember what side needs to be shaded, you can pick a point. I usually pick the origin, so 0, 0. And I plug that into my inequality. So I plug in 0 for y and 0 for my x. And I see if this satisfies the inequality. And so 2 is greater than or equal to 0. So I'm going to shade the side that 0, 0 was on. Now say I would have picked the point 1, 4, and I plugged that in. So 4 would be my y, and 1 would be my x. And I would get 3 is greater than or equal to 4. Well, 3 is not greater than or equal to 4, so therefore I do not shade above my inequality line. Okay, so to start off the lesson, what is a system of linear inequalities? Well, they're sort of like a system of linear equations, except they're inequalities. So for example, we would just have two inequalities that are in two variables, such as this one right here. And the other difference between a system of linear equations and a system of linear inequalities is the solution of a system of linear equalities is not the intersection point. It still is an ordered pair that satisfies both inequalities. However, there are usually many solutions rather than just one. The solutions correspond to the graph of the system of linear inequalities because the graph reveals all the solutions. So the main idea in these problems is you're just going to graph each inequality, and then you're going to try to find the region, the shaded region, that's common to both or all of the inequalities in the system, because a system can have two inequalities, or it can have three, it can have more. So that shaded region is the graph of the system, and it's going to contain all of the solutions to that system. Alright, so here's what I'm talking about. We need to graph these two inequalities. So the first equation I'm going to put into slope-intercept form. So I'm going to subtract 2x from both sides. I get negative 4y less than or equal to negative 2x plus 8. Dividing by 4y, just 4. And when we divide by a negative, remember that we must flip the sign. So we get y is greater than or equal to 1/2 x minus 2. Okay, so now that I have two inequalities in slope-intercept form, I'm going to go ahead and graph them. So the first one, y is less than negative 1/3 x plus 4. That hits the y-intercept at 4, and it has a slope of down 1 and right 3. And my line will be a dotted line because it's less than and not less than or equal to. So I'm going to dash this line. And now the shaded area. Well, let's pick the origin and test it. So 0 less than or negative 1/3 times 0, the x value, plus 4. And then I get 4 is greater than 0. Okay, so that is a true statement. That means the area with the origin is shaded. Now I'll graph the other inequality, and the y-intercept is -2, and the slope is up 1 and right 2. And this is a solid line because it's greater than or equal to. Now to figure out which side of the line is shaded, I'm going to pick the origin again and plug it into that inequality. So I'm going to get 0 greater than or equal to 1/2 times 0 minus 2. I get -2 is less than or equal to 0, which is a true statement, so I shade the side with the origin. Now that we've completed step 1, which was graph both of the inequalities in the system, we need to do step 2, which is identify the area that is shaded for both graphs. So the overlapping shaded area is going to be all of this. So any ordered pair in that region is a solution to this system of linear inequalities. I want you to try this one on your own, so pause the video and graph this system of linear inequalities. Hopefully you were able to get a graph looking somewhat like this. So notice that the first equation, y-intercept is -4 and the slope is -1. And it's a dotted line because it's greater than. And the second equation has a y-intercept of 2 and a slope of 2, and it is a solid line because it's less than or equal to. The first equation should have been shaded above the dotted line, and the second equation should have been shaded below the solid line. And so you can see that this area here is the common shaded area, and that's the solution to our system. Now this is a system with 3 inequalities, which is okay. We're just going to follow the same exact steps, so we're going to graph all 3 of them and find the common shaded area. It's okay if you don't remember how to graph absolute value inequalities, but I want you to think about how would you graph this second inequality and this third inequality. So take a second to pause the video and think about how you would graph that. I went ahead and graphed the first inequality, and hopefully you thought about how you would graph the second one, which is a dotted horizontal line at y equals 4. And hopefully you saw that x less than or equal to 1 is a vertical line at x equals 1. And all the y values less than 4 need to be shaded in. And all the x values less than or equal to 1 needed to be shaded in. So the graph to this system is this little triangle area right here, because it's the common shaded area between all 3 inequalities. I want you to try this system on your own, so pause the video and good luck. Hopefully your graph looks something like this, and this one may have stumped you because of the third inequality, y is less than x. Well, what is the y-intercept there? It's at 0, and the slope is 1. That's the coefficient in front of x. So I plotted a point at the origin and I went up 1 and right 1, and it's a dotted line. And hopefully you can see that this little region here is the graph of my system, and it contains the solutions to my system. Okay, I want to go over one more example and then we'll be done with this video. So graph this system. Well, I'm going to put the first inequality in slope-intercept form. So I'll get y is less than negative 2x plus 6 divided by 3. I get y is less than negative 2/3 x plus 2. So when I go to graph the first inequality, y-intercept is at 4, and I go down 2 and right 3, and I'll have a solid line, and I'm going to shade it so that all my y values will be greater than or equal to that line. Again, you could have picked the origin and tested it to see which side of the line needed to be shaded. I'm going to go ahead and do that just to reiterate for you. And 0 is not greater than or equal to 4, so the origin would not be shaded. And now I'm going to graph the next inequality. So I have a y-intercept of 2. I'm going to go down 2 and to the right 3. And this line is dotted, right, because it's less than. My inequality tells me that all y values are less than negative 2/3 x plus 2. Again, if you wanted, just pick the origin and check it. So I'll do that again just to show you. And I'll get 0 less than 2, which is a true statement, so the origin needed to be shaded. So I did it correctly. So now we need to find the common shaded region, but it looks like this graph will never be have a common shade, right? There's this middle gap here. So that tells me that there is no solutions to this system of inequalities. But just because we had two parallel lines doesn't mean that you'll always have no solution, because this gray shaded area could have been over here if our inequality sign was flipped that way, and we would have had a common shaded region, which would be this. So that's why shading is important. But that concludes this video, so bring your questions to class tomorrow, and I'll see you then.